Okay, so I am Zachary DiMartini, and I will be covering certain substitution reactions of alcohols that we have learned in this class this semester. So these reactions were initially somewhat difficult for me because there are a decent number of them, and their mechanisms were not immediately obvious or apparent to me, not necessarily the most intuitive for me. So all of these reactions involve substituting the hydroxyl group of the alcohol for something else, most commonly a halide like bromine. The first of these reactions involve the reaction of an alcohol with a hydrogen halide like hydrobromic acid, and heating this to produce an alkyl halide and water. If a secondary or tertiary alcohol is used, such as tert-butyl alcohol, then this reaction will proceed through an SN1 mechanism. So this water will be the leaving group forming this carbocation, and the bromide ion will attack it to form an alkyl bromide. However, if a primary alcohol is used, then the carbocation that would be formed through an SN1 mechanism would be too unstable because primary carbocations are very unstable. So instead, this reaction will proceed through an SN2 step here, also producing an alkyl halide. So these reactions will work if they are subjected to rather harsh conditions, if they are heated a lot. So in order to carry out this reaction without heating it so much, other reagents can be used. Most commonly, these would be a phosphorus trihalide or thionyl chloride. These reactions are carried out in pyridine, and they can only be used with primary or secondary alcohols because the SN2 step here in this mechanism would have too much steric hindrance with a tertiary alcohol to actually occur. So for instance, if ethanol is reacted with phosphorus tribromide, then the same product forms as if ethanol were reacted with hydrobromic acid. It simply occurs through a different mechanism and does not need to be heated. The mechanism of this reaction, if it were reacted with thionyl chloride, would be very similar. Obviously, the product would be an alkyl chloride instead of an alkyl bromide. It should be noted that this reaction results in an inversion of stereochemistry. So if the reactant is an S enantiomer, then the product will be an R enantiomer. So a third kind of substitution reaction that alcohols can undergo would be a reaction with a sulfonyl chloride. This converts the hydroxyl group to a sulfonate ester, and these reactions are also carried out in pyridine. A sulfonyl chloride contains what is to the left of my pen here. However, tosyl chloride, this molecule here, is the most commonly used sulfonyl chloride in these reactions. So generally, the sulfonyl chloride will react with the alcohol to produce a sulfonate ester. And more specifically, 2-butanol can react with tosyl chloride in pyridine to form this molecule. And opposite to a reaction with a phosphorus trihalide, this occurs with a retention of stereochemistry. So if the reactant is in S enantiomer, then the product will be as well. They will both be S. So these are the main kinds of reactions, main kinds of substitution reactions of alcohols that we have learned in the class this semester. Two other topics that I have found to be difficult in this class include ring opening reactions of epoxides, and given certain reaction conditions, whether in E1, E2, SN1, or SN2 mechanism would be favored.